So let's get into the channel structure. Don't worry about the complex formulas there. I just wanted to put them up there so you know, have it as a reference when you get this material after the session today. You can find the frequency to channel mappings in a 3GPP spec, and that spec is in series 36, which is essentially the radio or the RAN access network specifications. So it's 36.101 is the tech spec for this. And the channel numbers are called EUTRA, Absolute Radio Frequency Channel Numbers, ERFCN. It's a mouthful, don't worry about it. This is similar to your Wi-Fi channels 1, 6, 11, or 5 gigahertz, 36, 40, 44. What they do is there's this formula that maps the frequency to an absolute channel number, and the channel numbers span every band that 3GP operates in. So every unique band, every channel is very uniquely numbered, and so this is a global numbering scheme for all of 3GPP. So band 48 is CBRS. It falls into the a portion of this table where they do the mapping from frequency to channel number. And that's the formula for you, where the variables there are, the low frequency is 3550 megahertz, and the offset, or the starting numbering for this band is 55240. So the way that plays out then is here's your frequency to channel number mapping. If you're like me and you will not remember this or memorize it, you're going to have to print it out and remember this, just like you would. You've probably memorized Wi-Fi channels just using them enough. Once you use this enough, maybe you'll memorize it. Until then, keep the table handy. Since there's no real concept of static channel planning in CBRS, though, you probably don't need to know it if you don't have to. Just know, like when you're looking at stuff in a radio, what that number means, where it references to, and if you want to look up the mapping, you can. The numbering actually happens on a 1 megahertz basis, but I've kind of condensed it down into 10 megahertz because that's the smallest channel width available for CBRS. So if you had 10 megahertz wide channels, that would give you 15 channels in the CBRS band. I've highlighted them in blue. Again, just like Wi-Fi, the conformance here is you reference the center channel frequency. So the center channel frequency for channel 55290, the top one on the left there, is frequency of 3555 megahertz. So 5 megahertz below, 5 megahertz above. If we look to 20 megahertz channels, then you would potentially have 7 20 megahertz channels available. This is one example because you can skew those channels to the low end of the band or the high end of the band because you have about 10 megahertz of wiggle room there. So if you're skewing it toward the low end of the band, these would be your channel numbers for 20 megahertz. Any questions on channel numbering? Yeah.
More channel reads. So is it like Wi-Fi that if you have, say, a warehouse, you have 3 CBRS access points, they're all going to be operating on a different channel?
So the question's about frequency reuse. So if, let's say in a warehouse, you said, if we have 3 radios and they're all operating on different channels, more than likely, yes. What we'll get into is cellular's SON capability, which is similar to RRM, or radio resource management. It's called self-organizing networks. It's the process by which a manufacturer's equipment will determine through the SAS integration what spectrum is available and then allocate that to a system of radios for the most optimal configuration. You can operate LTE on a single frequency, which is definitely doable. Licensed operators do this all the time. And that gets into more of later today when we get into LTE and how the protocol handles interference. The short answer is, unlike Wi-Fi, it doesn't do preamble detection and backoff. So Wi-Fi is completely blocking. If I hear a preamble, I have to defer and wait. LTE does not operate that way. Number one, all the radios have a sync process, and they can actually sync their frames in the time domain so they don't overlap, and they can schedule them so they don't overlap. And the other thing that they can do then, hold on, the other thing that they can do is, instead of treating it as complete backoff and deferral, they treat it as just interference, as raising the noise floor. So it influences the SINR noise floor for a given transmission, but I can still transmit at the exact same time on 2 different base stations on the same frequency, they're non-blocking. I just might have a lower MCS data rate because my noise floor is a little raised. That gets into some more, very technical design parameters of where your sectors are, where they're pointing, where their sectors are covering, and how much noise that introduces. But just know it's non-blocking. So, and that's what we'll get into as well when we start doing network planning, as we'll see if I start ratcheting down how much spectrum I'm using to serve a given capacity requirement, that the number of radios to deploy does not scale linearly with how much bandwidth I have, because I can actually reuse that frequency more often than, let's say, I could in Wi-Fi. You still need to do some channel planning potentially, and the SON will try to take care of that dynamically in the system, but it's just, I would say, not as impactful as in Wi-Fi, if that makes sense. Question? The question is, can we expect a capacity planner from me? No, not me particularly. Celona has one that I'm going to highlight later on today in the planning section. We have a web-based tool that can give you a rough order of magnitude of how much spectrum you have available at a location and how many radios you need. We'll go into that.
So the frequency coordination and the time domain coordination of this section is a TMA variant.
Yeah. So the question is, the frequency coordination for interference in CBRS specifically, since CBRS uses TDD LTE, or time domain duplexing. It's TDMA, essentially that same concept, yep. But all the radios are syncing up through their EPS or through the system, since LTE is more than over the air spec. LTE is the portion of the over-the-air spec. The other one is the EPS, or the Evolved Packet System, which is the packet core and all the control plane functionality and all that. It operates as a system, so as a system, it can sync those radios up to coordinate that in the time domain so that they don't interfere. Yeah, question?
So when you deploy CBRS, you check in with the SAS data,
Mm-hmm.
it tells you what spectrum is available. Is that the same for low power equipment as it is for higher power?
So the question is, when the radios at CBRS check in with the SAS for power levels, is that the same for low power and high power, category A and category B devices?
I said if you're a low power deployment, it doesn't really matter what's being used mile down the road, because
Yeah, so both category A and category B are required to integrate with the SAS, request spectrum, and the SAS does modeling. So when what you're going to go into the CPI training when you get the voucher for that and go through that training, they're going to tell you what those specific requirements are and how the modeling happens. The modeling, so when the radios register with the SAS, they actually register not only their GPS location, they register their install height, their antenna gain, and azimuth, which is orientation, so that the SAS has all the data it needs to accurately model the RF propagation and impact. And the ranges that it models for indoor are less than the range for outdoor. So yes, it still does all the modeling for the indoor, and so it'll actually model indoor radio interference with, let's say, your neighbor as well, to understand what the best frequencies are to potentially allocate. And then from there, any given enterprise's SON aspect of their own infrastructure would then optimally delegate those radios out to the different radios, or those channels out to the different radios. So the interesting thing we'll get into is there's a concept of a domain proxy, where not every radio has to check in with the SAS. It can be offloaded to a centralized element. In Celona, we implement our domain proxy in our Celona Edge, which is our packet core. So let's say you have 100 radios across this building. The domain proxy in the core is going to integrate with the SAS, know the specific location of every one of its radios it's managing, and each radio could have a different subset of that spectrum that the SAS is saying is available for it. So the ones on this edge of the building are next to a neighbor. That neighbor's already operating on these specific channels. So to avoid that, maybe you have a different subset available on these 4 radios than the 10 radios over on the other end of the building. So every radio will have a different subset of frequencies that the SAS will grant it, and that's the job of the domain proxy, is to optimally figure out what the best arrangement of those channels are for frequency reuse, non-overlap, and performance.
That's a
The question is the domain proxy a customer-owned device, and it's yes. This isn't, we're talking about enterprise-owned and controlled deployments. So for CBRS, by and large, it's either going to be the enterprise owning the radios and its own packet core and all the related systems, or it's going to be like a partner and a managed service provider that will own it and help the customer through that process, but completely controlled by the the enterprise or the community.
Do the radios use Ethernet as transit to the core, or is it some other proprietary transit?
Yeah, so the question are, do the CBRS radios use Ethernet as its transportation to the core or its backhaul? The answer is yes. Most CBSDs or CBRS service devices, which are the radios, use either Ethernet, Cat6, or they use fiber. They're kind of like a cellular small cell, essentially, is what the terminology is from a cellular perspective. I have yet to see one that doesn't support one of those two methods. I mean,
Anything makes it into an IP network, or do they have to be completely segregated networks?
so the question is, does it work on an IP network, or do they have to be segregated? It's dependent on the manufacturer's implementation. So if, let's say there's an MNO, like Verizon or AT&T is coming in to try to sell you private LTE, they might want it completely dedicated and they want to run their own fiber, they want to control everything and just sell you private LTE. The Celona approach that, I don't want to, this is a vendor specific thing, is we integrate with an enterprise's existing network. So our radios are just like Wi-Fi APs. They plug into your switches, they use your cabling, you plug in the packet core, which is the Celona Edge, into your network. You have routing, you have firewalls, you have everything in between. This is really an overlay to your existing enterprise network.
How does the certified engineer do their planning to provide that information?
So the question is, how does the certified engineer do their planning to provide that information to the SAS? Yeah, so really it comes down to the technician doing the install doesn't have to be the CPI certified individual. The CPI certified individual is just the one taking accountability for the system. And that's really mainly for outdoor or high power installs. So there's a process that, again, going to be manufacturer dependent to make sure that you have correct GPS coordinates for every radio installed. Outdoor, more than likely, that's going to look like GPS units that are bundled into the small cells. Almost every small cell is going to be manufactured with GPS built in. It might look like a separate little antenna off the system. It might be an integrated antenna. Indoors, where GPS is harder to acquire the signal for, then it's going to be a manual or automated process within the manufacturer's specific system to assign GPS coordinates. So that could be a technician that has an app on their phone that can acquire the GPS signals and dynamically map it to a radio, or it could be manually putting it in the system somehow, or somewhere in between. It's pretty much implementation dependent.
In terms of design, though, how do you do a design to provide specs and height and capacitance?
Oh, yeah. So the question is, how do you do the design for the CBRS radios? I'm going to get to that in a CBRS planning section just a little bit later today. We'll go through essentially predictive modeling as well. Well, we'll go through the Celona network planner for how many radios you need given capacity and location. We'll go into very specific predictive modeling, just like you're familiar with Wi-Fi. You'll do an install. You can also do a site survey afterward of live measurements. Very similar process to how you do it with Wi-Fi, just a little bit different technology underneath. Is there any other question? Yeah. Can you speak up a little bit? I can't hear you. Oh, if there's a quality service mechanism in this technology, yes. It's very complex. We're going to get into it later today in the LTE section. So I don't want to dive into it now because it can be a kind of lengthy topic. We're going to get to it though, yeah.
So it's technology dependent. So if it's LTE, it would be kind of LTE. What can service something different?
So the question is it technology dependent? Like LTE, it'd be LTE's QoS. If it's 5G, it'll be 5G's QoS. Yes. So CBRS is just the spectrum. How you use it, what protocol you run over it is going to be LTE today, 5G in the near future. And LTE has very well-defined QoS with EPS bearers and things like that we'll get into. 5G has analogous QoS mechanisms.
Yeah, regarding the Ethernet connection to the backbone, what speeds would normally be? 1 gig, 1.5, 5?
Yeah, so remember right now with CBRS, the question is what speed will we need on the backhaul? Remember with CBRS Spectrum, the largest channel width right now is 40 megahertz. maximum of about 200 megabits downlink and 50 megabits uplink. So today, you don't need anything more than a gigabit Ethernet connection. Okay, so on the FCC side as well, some of this, licensed by rule, they have spectral limits that you have to comply by. So for the infrastructure side, or CBSD, it operates on a specific channel. What are the out-of-channel spectral emissions limits, and then what are the out-of-band limits? So within 10 megahertz of the operating channel, it has to reduce power output by 13 dBm per megahertz. Greater than 10 megahertz away from the operating channel, and it has to drop by 25 dBm per megahertz. So that's kind of the, you're used to the OFDM shape and spectral limits from Wi-Fi. This is very similar for OFDMA with LTE and CBRS. The further away you get from the operating channel, the lower the power output and emissions can be. End user devices, they're a little bit more flexible. So instead of within 10 megahertz of the channel and greater than 10 megahertz, it's based on the channel bandwidth. So client devices are usually cheaper quality devices. They can't conform to the same RF front-end capabilities, so they allow them a little bit more latitude to have spectral emissions away from the operating channel. So for instance, if it's a 10 megahertz channel, it'd be identical to what the infrastructure requirements are. But for larger channel widths, they give them a little bit more latitude to have the power drop off a little bit more gradually.
This is part of the certification.
This is all part of the certification process, yep. So again, a geeky detail I like to throw into my presentations, just so you have it in there to know what the spectral emissions limits are. Architectural overview, so I got into this a little bit. So this is getting into the WinnForum and how the SAS operates. So again, we have CBSDs that can integrate with the SAS directly, with CBSD4 here, for example. Then you have other CBSDs. Let's say if the architecture is that we're going to do it in an aggregated, centralized fashion. You could have a domain proxy running typically on like the packet core type of solution that aggregates a number of radios and integrates with the SAS for them on their behalf. And then we have the SAS to SAS interfaces, so the SASs on the back end have to sync up. So if I'm integrating with any one of the SASs as an enterprise, I'm not integrating, let's say, with all 5 of them. If I get a grant for a specific frequency or channel at a specific location, all the other SASs and all the other enterprises that are deploying have to know about that to compute the models correctly. So all the SAS vendors on the back end sync their databases. Right now, that's being done nightly. They have enhancements that are coming to do that in more real time. That's going to be a maturation process for the SAS vendors over time. And then the SAS vendors do the ESC as well that feeds into the system for the incumbent detection. So that's kind of what the integration looks like. As an enterprise, you really just need to think about the lower portion with the radios and the domain proxy functionality.
SAS vendor get a specific geographic area in the United States, or
So the question is, are the SAS providers geographically segmented? No. The answer is all 5 of them can operate. They can control any and all portion of that 150 megahertz. It's just a matter of each enterprise and each manufacturer, which SAS vendor they partner with and which one they integrate with. And they're all required to sync up on the back end. So each SAS knows about everything nationwide that gets registered. Question?
Us as an installer or an enterprise, we can make a decision on which one we want to partner with?
So the question is, you as a partner or as a customer enterprise can pick which one you integrate with. More than likely, it's going to be bundled in with the manufacturer solution that you purchase. So the manufacturer is going to integrate, they're going to do the coding and development to integrate with one or multiple SAS providers. So for instance, Celona integrates with both Federated Wireless and Google right now. So we integrate with 2. And if you bought our solution, it would come with the solution. So really, enterprises and partners probably don't even need to think about it. As long as the SAS vendors are certified doing their thing on the back end, it really doesn't matter which one you integrate with, as long as it's operating normally. Okay. So here's where we get to those CBSD categories. So category A is the low power, category B is the high power. Category A no CPI requirement. Anybody can install it as long as it's certified and integrates with the SAS. It does have some restrictions. You can use it indoor, or you can use it outdoor at less than 6 meters height, and it has a 30 dBm EIRP limit. So that is what defines a category A, is really 30 dBm EIRP limit, and if you're doing it outdoors, which you can, you're limited in height. Category B, the high power, a CPI is required for this. You can deploy it outdoors only. You're not to deploy these indoors. And it can have a much higher power of 47 dBm, which is 50 watts. So you think about it, between the transmit power and the antenna gain, you can potentially cover several kilometers outdoors with one single category B CBSD unit. So one of the big benefits of this is large outdoor environments that need coverage, or the density of a Wi-Fi deployment might not be feasible. This has much, much larger coverage range than Wi-Fi can outdoors. And then geolocation capabilities. So again, especially for outdoors, you have to put in the GPS location, or it has to dynamically register with the SAS. It has to be plus or minus 50 meters in the horizontal and plus or minus 3 meters in elevation. So that's the accuracy requirement that it has to be able to achieve to integrate with the SAS and determine its location. Yeah, question?
This might be a silly question, but since category A can be installed by a non-CPI, say they do outdoor that's 8 or 10 meters high, how is that regulated?
Yeah, so the question is if anybody can deploy indoor, or if they do it incorrectly potentially, how does that get detected and regulated? As far as I know, that's an FCC enforcement action. So they would get flag detected somehow by, let's say, a neighbor that they're getting interfered with or something, and somebody would file a complaint with the FCC. The FCC might go out and investigate and actually fine you for non-compliance. The difference is, since you're not having a CPI, there's not an individual that is individually held accountable. It would probably be more at the organization level. When you get to outdoors, there's a very specific CPI. When you sign off on an outdoor, or a category, I should stop using outdoor, a category B CBSD, you put your name in the registration database, and you are personally accountable for that. So, when you go through the CPI course that we're going to give you credit for through Federated Wireless, just understand, if you're signing for a CPI, as a CPI for an install, you're putting your name personally to that. And the FCC could, come back for you personally for liability. So it's a very important deal, and that's why, it's very well-defined, certified installer process.
Well, Andrew, on category A, since in theory you're buying some equipment and it's checking into a database, could there be some way, say, hey, I know this is sold to Sean, and Sean incorrectly installed it? Would there be some kind of tracking that way?
So the question is, they're tracking on a device. Well, see, the thing is, if you're abusing the SAS integration and falsely identifying its location, yeah, it's probably registered in the SAS somewhere, but you don't know exactly probably where it's coming from. It would have I'm assuming there's probably a unique identifier that if you go and you can sense it, then you can look it up in the SAS and determine it was, registered in the wrong location or the wrong power or something like that. I don't know technically how that happens on the back end, but it is uniquely identifiable as a specific radio and tracked to then what organization has that registered, yes.
Say, you sold me a serial number XYZ or something like that, and I can say, hey, look, this device over here is doing something. And then I would assume there'd be some type of reporting back to say, hey, Celona sold a device to Sean's doing it incorrectly, let's check in on that.
Yeah, I don't know exactly the specifics of how that would work. But they do check in and register with the SAS individually and uniquely identifiable. So the process, you deploy radios in the network and they register with the SAS, or that can be through a domain proxy. The process for integration with the SAS then is you deploy them, they inquire with the SAS for what spectrum is available in that specific location. The SAS returns the list of available frequencies for that radio. So that's called the spectrum inquiry process. So you're inquiring with the SAS what's available in my location. Then you have a grant process. So through the grant process then, the radio or the domain proxy picks a very specific channel that it wants a radio to operate on. I go out and I do a grant request for that channel, and the SAS can either approve or deny that request. And then you can start operating on that channel if it was approved. So through the Spectrum inquiry, you could actually get back a list of channels that are available. You pick one and then you try to get a grant on it. If you've already done the inquiry, I mean, you should be able to get the grant. Technically, you could ask for a grant on a channel without doing an inquiry first and just like saying, I don't know what channels are available, but I just want this one. And then the SAS might deny you. Question was, do I expect that to be automated? Yes. I expect this to be automated with so at the radio level, there's already firmware in almost every small cell that you could integrate the radio with SAS directly. From a packet core perspective, that's through the SON or self-organizing network. And many manufacturers are developing the SAS integration automated in their SON algorithms, yes.
So you said there's a mechanism similar on our end for this. How often might the channel change?
So the question is, how often might a channel change? Through SON, it's really implementation dependent. If there's any change in neighbors that they want to optimize around. Incumbent, probably fairly infrequently, but once it gets more widespread, it'd probably just be other people using GAA channels, and you want to optimize. So there's no real set limit. It's implementation dependent, I should say. In the early days, I wouldn't expect it to fluctuate very much, and I expect most manufacturers to probably put in some controls around that algorithm to say, have it run every so often in my network. I'm going to skip that one. Skip that one. So other spectrum globally opening up. So in the US, there's also spectrum in the 3.4 to 3.55 gigahertz band. So NTIA is looking at the 100 megahertz directly lower than the CBRS band right now. So that's very interesting. So if that moves forward, then we could potentially have another 100 megahertz directly adjacent to the CBRS band. 3.55 to 3.7 is already available in Germany. The UK is looking at 3.4 to 3.6. It's a little bit different use it or lose it type of lightly licensed spectrum. And then we can also look at LTE and private LTE and 5G operating in unlicensed. So when 6 gigahertz opens up, it might be an opportunity to use some of that spectrum for private LTE as well. So as enterprises are deploying into the 6 gigahertz band, you could potentially say, I want a portion of the 6 gigahertz to be Wi-Fi 6E, and I want a portion of it to be used for private LTE, and you'd have control over, how you use that unlicensed spectrum.
So would that be with MultiFire?
So the question is, would that be with MultiFire or a different protocol? Kind of TBD on that one. I don't know yet. MultiFire is kind of dead in the water, so I wouldn't anticipate it to be MultiFire. I would anticipate it to be private LTE, just like CBRS, only without the SAS requirements, since that would be unlicensed spectrum. Carriers are going to look at it as LAA, so it's still a very political battle as far as how those protocols interact. But the good news is if you're deploying private LTE, you would control which channels you would allocate to which technology potentially, and so you would be in control of, segmenting those apart from one another if you wanted to.